ANZBIG's first webinar and podcast series. I'm Don Coyne, the current CEO of ANZ Biochar Industry Group, or ANZBIG, and I'm joined today by Sam Sagami, our cluster manager. ANZBIG's overarching KPI is to assist the growth of the sustainable production and use of biochar in Australia and New Zealand. We are a not-for-profit organisation with a strong and growing membership base, focusing on policy, standards, communication, market intelligence and research. Biochar is now recognised by the IPCC as one of 6 negative emissions technologies that can capture carbon, utilise and store it for up to thousands of years. The carbon removal industry is estimated to be worth by 2030 worldwide. So you can join ANZBIG today and help this important industry grow.
Now, many people new to biochar are actually surprised to hear that it can not only be used in agriculture, but it can also be used in infrastructure. And in fact, biochar can be used in a variety of industrial applications, including roads, concrete, asphalt, just to name a few. And on today's show, we welcome Foundational Member of ANZBIG, Founder and Director of NewWorld Pavement Solutions and CarbonCor Products, Andre Vanzile. Now, Andre is a chemical engineer who has specialised knowledge and skills in road surfacing technology, especially in the development of manufacture and installation of environmentally friendly emulsified cold road premix material for both new, urban and remote infrastructure development areas. He has been instrumental in the further development and redesign of new revolutionary CarbonCor product range of road and construction materials, which are now available and being rolled out internationally. Andre resides in Perth, Western Australia, and we're really grateful and very pleased that Andre has agreed to join us today.
Thank you.
Welcome, Andre. I'm glad you settled in Australia. So firstly, for our viewers and listeners today, this interview is designed to stimulate an increase in the sustainable production of biochar in Australia and New Zealand, and that means a higher uptake of your products, Andre. So by the end of this interview, participants will understand about the avoided emissions, carbon sink and economic potential of installing more of these environmentally friendly emulsified cold road premix materials with up to 20% of biochar in them. So Andre, why did you focus on the development of cold asphalt mix instead of hot?
I think, first of all, just a welcome to everybody and thanks for attending, and a special shout out for ANZBIG, Don and Sam and Andrew Kinden setting this whole thing up. If we step back 10, 15 years, the development of mines predominantly out of Africa, obviously I started the whole thing out of South Africa. But developing mines in Africa and in remote and rural locations, you initially need construction roads and then haul roads and in-plant roads, and where a new mine starts in the middle of nowhere, there's always a little town that's starting, and then they get a mayor, and then they get a shopping center, and there's no hot mix batch plants available in these remote locations. So predominantly people use non-environmental friendly, all the heavy oil and truck oils, and then later on it into concretes. But cement, Portland cement concreting works. It's expensive if you're in the middle of nowhere. So we started the development of being able to manufacture a product at a location and have at least a 6-month shelf life, transport the product to the other end and install it. And obviously the performance needed to be the same or better. And that's how the whole cold premix side started. I might add at this stage of the game that the predominant cold premixes in the world are cationic based, so solvents, and more for repair maintenance, as I cannot get enough sufficient fines into the product to make it stable under heavy-duty conditions. Ours is based on a high pH anionic development, or an anionic bitumen-based emulsion, and it includes, it requires a source of carbon. See later on there's some questions regarding why on the performance side, so I'll get to that a little bit later on. But it's to be able to build roads in the middle of nowhere. That's the first answer.
Great. And Andre, what are the chemical reactional benefits of using biochar in the cold mix?
Well, if you look at your standard hot mix technology, it's based on ionic bonding mechanisms. It's based on adhesion and cohesion bonding structures. We've come up with a process whereby by introducing a little bit of carbon, and that carbon can be in the form of initially coal fines. We've used carbon black. We've used incinerator ashes, and in the last few years moved over to the cleaner biochar source for the carbon. That starts giving you a carbon covalent bonding mechanism, which if you look at the chemistry of it, covalent bonds are a lot stronger and more enduring and more flexible than what the ionic bonds are. So by introducing a carbon source and covalent bonding mechanisms, it significantly increases the performance of the product. And being cold with no solvents present, we can also add things like UV inhibitors for the layman suntan lotion. So we have a lot better resistance against surface oxidation of the bitumen, etc. So I think the technical discussion on this is 3 hours.
Okay, and Andre, I guess the big one is, what are the economic benefits of using in the cold mix, would you say?
I think there's a long list, but from a basic point of view, if you do hot mix asphalt installations, many countries have different specifications in designs on it, but predominantly, if I can hold this up, this is a Marshall core from a standard hot premix situation, which wearing course layers needs to be minimum 55 millimeters thick for heavy duty, and with the introduction of polymers and all kinds of other warm mix technologies, they've managed to come down to a 30-40 millimeter, but that's then not for heavy duty application. Now, when we do a product, we never install thicker than this. This is our standard cold premix. There's the hot mix equivalent. So if you start lobbing together savings on transport, savings on material, savings on handling, savings on no solvents, no heat involved, and that purely becomes relevant or works back to the biochar. So with the carbon content in there, it kicks in many cost benefits as well. Maybe on that point, just a quick reference. There's a lot of very good work being done all over the world, here in Australia as well, whereby they're getting biochar into hot mix applications, but that's a percentage of the binder, a percentage of the bitumen. If we say that we're putting up to 20% biochar into a mix, it's 20% of the final mix. That's huge amounts. It can run up on soil stabilization and wearing course combined. It can go up as high as 170 tons of biochar per kilometer of road. That's a lot of sequestration.
Wow. Mm. Yes.
And I suppose that leads perfectly into our next question, Andre, which is just about the environmental benefits of using biochar in the cold mix or in bitumen in general.
I think there's two main divisions for that matter. The first off is environmental benefits, straightforward, of putting biochar in anywhere. If it's soil carbons, if it's into cement, concrete base, if it's if it's a cow fodder, food fodder, fish food. There is worldwide and well recognized benefits for utilizing biochar. If you now look at the fact that if we put biochar into a mix, and that can be standard black wearing coarse asphalt, it's a cold premix. It's very easy to do. If you get some light on it, very easy to do color versions now, because we can use modified biochars to bring out colors. We can use straightforward soil pindan materials from local, a combination of pindans and natural gravels. As long as we add the biochar in there, it starts giving it the flexibility, and we get the binder mechanisms to spread. We can do all kinds of reclaimed waste materials into the mix as well. So from a straightforward clean biochar side, many benefits well documented in the world, all the way up to the fact that you can now start earning carbon credits for every ton of biochar you sequestrate. On the other side of it, with the superior bonding mechanisms that we developed together with the biochar, we can now start adding in, and we do that already, reclaimed plastic waste materials, reclaimed or contaminated bio-wastes and biomasses, because biochar absorbs things like heavy metals, selenium, cadmium, and together with our binder mechanisms, we make the whole mass unhurt. Also, on top of that, because of the biochar content, we can now make lightweight building construction material from wastes and slurries and reclaimed bricks, and it's all a cold process, easy to install, lightweight compaction equipment needed only, and with the weight of biochar, it's a lot less transport costs as well.
Yeah, I mean, like, it's really great to hear the different ways that you can utilize waste, and especially plastic waste is such an issue all around the world, and it's really great to hear that, you know, there are ways that we can use biochar, and biochar has to offer with sequestration and and dealing with the waste, the plastic waste as well.
No, that's also important to realize is we are very far down the line of doing combination feedstocks to pyrolysis units, whereby we run on 30% biomass of any kind, plus 70% waste, which is predominantly plastics and tarpaulins, and we are also now doing partial pyrolysis of tire and conveyor rubbers, and we are adding that into the mixtures. So it's happening very fast. But the one thing that we have to understand is carbon sequestration itself. If we put a ton or 170 tons of biochar into a kilometer of road, if that biochar came from an audited supplier that's already claimed carbon credits, you can't double dip on those carbon credits. But more significantly is the emissions avoidance that now is associated with this product. The fact that we don't have to use stock standard quarries and you know that carbon footprint associated with blasting, crushing, screening, washing, and transport of massive amounts of aggregates to the middle of nowhere. We take those emissions, we take that out of play. So that's a carbon credit in itself. And then the fact that we install a lot thinner, because the stuff is a lot more performance, stronger and better. And we don't need solvents, we don't need waste heat. And on top of that, the reclaimed waste that's in there is material that did not have to be landfilled.
Yeah.
So, you know, the package is actually big enough for many people to sit around and try. We are still trying to get our heads around all the savings, purely because of biochar.
Yeah. So look, I'm going to jump to the next question, Sam. So if you go back to the previous one, so we'll swap.
Yep.
So that kind of leads in, Andre, to what is the best biomass or feedstocks to make biochar for your cold asphalt mix?
And I think I will link that to a cost scenario as well. And that's one thing that maybe one of the most important messages I want to get over the line today is the fact that we can make use of a high-cost biochar. So that's your clean feedstocks in clean process. Yes, we all would love it. We would all love it to be absorbed, as soil carbons or crop enhancement, etc. That's always been the case, and that's still a very important part of the business. But that equates to 5 metric ton per hectare. For a kilometer of road is the same as 1 hectare. We can put 170 tons in. As we stand now, the prevalent biochar available are the clean stuff. If we we can include up to 10% clean biochar at cost levels of $400, $500, $600 a ton. We can include that into our road products, and we are still cost effective against conventional installations. If we now can increase biochar production by consuming waste, recycled waste, by consuming contaminated waste, so now it cannot be appointed as a soil carbon. Let's leave the clean stuff for the clean applications. But we can take the not so clean. It's not contaminated anymore. It's just not so clean. We can take this not so clean material, and we can ramp up production of it, because it does not have to be dried. I have some samples here. I don't know if you're able to see that. Some of the biochar is a stock standard, very granular biochar, which we can modify actually all the way up into a little aggregate. And it has to be dry if it goes for most of the applications in the agricultural industry. This is fines that some of it is partially pyrolized. It's chunky. It's still a bit damp. It's still a bit wet. We don't have to dry it, because if it's not dry, we will wet it before we put it into our production systems. So the whole biochar thing. There's so many angles to it. There's so many ways and means of increasing the demand for biochar, so that more people jump onto the platform and start manufacturing biochar. We can use the cheap stuff, obviously, but we can also use the extensive stuff and still apply it cost effectively. And that is the message. Guys, if you can make biochar, doesn't matter what it costs, please make it. We want it.
And I suppose, Andre, you kind of touched on clean biochar and, let's say, like non-clean biochar. Would you say that it's the biomass waste, for example, that would be defined as clean, and then the tires, the plastics, those sorts of things would be the ones that you would then put in roads? Is that what you mean by that?
Yeah, well, okay. I think there's pyrolysis processes in the world that can take even dirty feedstock, contaminated feedstocks, and pyrolyzing at 850 degrees with special this and special that. And they can come out with a clean biochar that can be used for agricultural applications. But that's an expensive process, high capex. So if you tone down now, if you have, there's so much biomass in the world now, contaminated sewage, contaminated salts in estuaries, PFAS contaminant. I mean, half the world has been on fire, and Turkey is on fire, and Greece is on fire. The amount of contaminated biomass now being produced, if I can put it that way, is extensive. So what are you going to do with that? We can put it in as a construction char, because our binder mechanism makes it inert. It's the same thing with the problem area on Kangaroo Island at the moment. Massive amounts of plantations burned away. They don't know what to do. They need to clear. They need to go somewhere with it. Let's go in there and let's make biochar left, right, and center because we do need it for construction.
Right. And where are your emulsion plants located in ANZ?
At this moment in time, I'm in Darwin at the moment. Actually, well, we both based in Perth, but I came up here to commission the. We upgraded the existing plant here. Came up here to commission it now, and I got caught in COVID lockdown in Darwin. Can you believe that? So I decided to stay on. So we have a full-on operating plant, emulsion and mixing plant now in Darwin, fully commissioned. Very soon, in the next 3 weeks, we will commission an even bigger plant in Hayden, Western Australia. It's close to Wavrock. From these two locations, we can already transport emulsion all over. We already supplying emulsion up into the upper end of the wheat belt, into Pilbara, Kalgoorlie, all those. We can ship emulsion to various locations. By early next year, we will have an emulsion and mixing plant up and running in Victoria. And then soon after, plan another one for Brisbane area or Harvey Bay. So plan is to, by the end of next year, we will have 7 plants fully operational in Australia.
Wow, it's really amazing, Andre. It's great to hear how things have really expanded in this time for you and your company. It's really great to hear.
Yeah. So look, yeah. Go on. Sorry.
It's the ability to construct roads, hard stand areas, do erosion control, do dust suppression, very economically in far remote areas, utilizing local in situ soils. That's where we're going. And biochar. So we need a little pyrolysis plant up and running in every small town.
Yes. And that leads to the next question, or there's actually a few questions here. So how do you see the biochar production for roads rolling out in ANZ? What are the hurdles for biochar and your products being accepted in Australia and New Zealand? Jobs do you think you could create, and how much dollars is it going to be worth to the economy overall?
That's a big question.
$1 million questions.
The first question, Andre, let's start basic, shall we? How do you see biochar production for roads rolling out in ANZ?
Well, first off, now we have already created quite a significant amount of biochar. Our products are not fenced off, for needing only biochar. We can use any carbon source. We even using an incinerator ashes and fly ash and bottom ash. But we prefer the biochar. Obviously, the future currency of the world is going to be carbon credits, so it's something to look at as well. But by creating a demand for biochar, more and more people are starting making biochar. You can utilize all these large-scale, expensive units. Power plants, 1 megawatt power plant. We are going the route of putting in 1,000 small ones. The bigger ones takes years and years on EPA. There's a lot of politics and environmental legislation that needs to be overcome. There's a number of systems in place that is already certified up. We've done a lot of work in developing special biochar filter units that we put into small scale and medium scale and developing technology kilns so that we can get it past EPA quicker. So the biggest hurdle here is to get the EPA to sign off and say go ahead. That's the single biggest hurdle. If you scale down, you get through quicker. The future of biochar is going to be the ability to manufacture it on small scale, remote locations, as many as possible. That biochar can be used. We've now up to the stage where we take a chunky biochar and we modify it with an emulsion, and it can be used as a lightweight aggregate. It can also be used as a cement-like addition to local soils. No Portland cement required. None of our products use Portland cement. And you can make guard stand areas and light-duty remote roads straight with a modified biochar and water and soil. And so if everybody starts putting up small little kilns and gets it going, and then 10 years from now, this can be it's got the potential to be a 1,000,000 ton a year production commodity. We just need to get going, and that's what we're doing. We're closing eyes and we're just putting up plants left, right, and center. We obviously using a lot of biochar in the Asian countries already as well. There it does go a bit quicker to get past the environmental hurdle, and the need for a product drives the expansion. In Australia, as a last point, in Australia we now find specifically all the mining groups, because they need offset carbon credits, and if we put 10% biochar into the products, it's basically scarifying the existing roads 50 mil thick and putting in a biochar emulsion mix and compacting it down again. That gives them bucket loads of carbon credits that they can offset against other projects.
Yeah. And you kind of touched on a couple of the hurdles, and this was one part of the question, is just, what are the hurdles of biochar and, your products being accepted in Australia and New Zealand? One of them using the EPA, for example.
Yeah, I think it's the lack of a classification system for biochar, because biochar currently is being, classified or certified predominantly for feedstock and medical and agricultural. If anybody talks about if there's any chance of a contaminant in the biochar or in the feedstock, then the wheels just stop turning. So our process, to put it in layman's terms, your agricultural or feedstock or wood vinegar, I'm not an expert on that side of it, but those systems are designed to get the biochar as clean as possible. So emissions is a problem, and I think that's been a hampering effect because of long EPA and approval systems, because emissions are always contaminated, and you need to keep that in. Now on our side, it's exactly the opposite. If you picture it as a microwave oven, we turn the dial so that all the nasty stays in the biochar and the emissions is clean. So we turn the dial of the unit until the emissions are clean. Tick off, sign, go for production. The nasties or the contaminants stays in the biochar, and our system makes it 100% inert. We've done up to 28-day leaching tests on ambient and as high as 70 degrees centigrade, and there's no leaching. Biochar absorbs everything, and once the biochar is gripped it's going to hold on to it. So the overcoming one of the stumbling blocks is these long approval legislation. The other thing to overcome it, which I think, and people laugh when I say it, but I think one of the biggest problems in the world for biochar is people do not know what biochar is. They haven't heard of it. They, if you go to Bunnings, you get horticultural charcoal, and I struggle to pronounce that word. So we are putting products now easier. We're putting a lot of effort into brand building up there, and obviously one of our biggest missions, COVID has now put a little bit of a spoke in the wheel here for the conference scenario, but we'll do one or 12. But if we don't do a big one this coming October, we'll do a massively internationally linked one next year in March. But make the world au fait of what biochar is and what you can do with it. So
Yeah, absolutely. And I think, that's a couple of the things I suppose ANZBIG's doing as an organization is coming up with our code of practice to be able to have those classifications, so then that way it is more widely accepted, and talking to the likes of the EPA and engaging with politicians and decision makers, so then that way it can be widely accepted. And I think things like today of getting someone like you on, Andre, so then that way you can talk about it. That gives us the flexibility or the ability to be able to make it more accessible for people, so they can hear about biochar and hear about the story and hear about how it can impact in very different ways. So that's great.
We're a bunch of passionate people together, and we've been driving this mostly out of a passionate point of view. But at the same time, we are creating the commercial side, whereby the value of a carbon credit, whatever it's worth now, if it's $20, worth $20 now, in 5 years from now, is going to be worth $200 if it's not 2,000. And how do you overcome these hurdles? You can go and struggle and talk and design and engineer and do scientific papers. If you create a value, everybody's going to jump on the wagon. Everybody wants this. Everybody realizes, whoa, if we do this, we're banking this. We're saving. And for me, I just want to get down. I want to get the CO2 footprint and global warming. We need to do something. If we don't, our children is going to suffer. So so the way to do it is to create a system, a carbon accounting platform for construction char, if we can call it that. If the moment you put an official recognized, Puro equivalent, but for construction processes in place, then you're going to start winning. And this is not only about sequestration of carbon, this is also about emission avoidance, which is massive. And then on top of that, our binder mechanisms now outperforms, and we have a number of university studies on it. Our binder mechanisms outperforms the use of Portland cement. So if you eliminate the use of cement, then you have something, and we've done that. I mean, we call them low cost housing materials already, but on flexural, modulus, flexural, resilient modulus, indirect tensile modulus, fatigue-based performance test work that we've done, we outperform the standard conventional products by a factor 4 or 5. But to get it certified and signed off, that's how quick can we do that? If you do it in remote and rural applications, it gets done a lot quicker than in the big cities.
Sure. And just the last piece of the question that Don originally asked was, how many jobs do you think we can create, and how much dollars is it going to be worth to our overall economy, would you say?
Well, we are putting together a little model plant now in the small little town of Avoidance that will include a plastic waste processing facility, plus our first kiln is arriving soon. It's tarpaulin processing. People don't realize that in Australia, CBH landfills thousands and thousands of tons of spent tarpaulins, and there's many other plastic-based waste that gets landfilled. We can stick all that through a pyrolysis or partial pyrolysis process that is environmentally and emission friendly. And then the cold mixing plants, the emulsion plants, a total plant complement, so a full closed loop plant, as we call them, will employ somewhere around 50 to 60 people. By the end of this year, by the end of next year, we're looking at least 7 plants. It looks like it's going to be more, but I mean, I'll be happy if it's 7. So primary employment, 50, 60 people per plant. Secondary employment, if you look at all the other things associated with bringing and taking and handling and invoicing and insurance and all that, you're now looking at 1,000, I think. I mean, I'm not an expert on that, but the clever boys have said it's somewhere around 1,000 to 1,500 per plant. So, yes, it's not going to be, a massive employed, but it's going to be high level, high skill, high revenue applications. And for the governments and for the for the country, we need to drive population growth. We need to drive taxes. The more people we put in paying higher taxes, the less taxes you're going to pay overall. So, and the other big advantage we currently have is the international interest on what we are doing. So this can become an export technology for a country like Australia, which is good. It brings back manufacturing. We do all our equipment manufacturing locally now. And then obviously the after-sale service, spares, and everything is Australian made. So we're quite passionate about that.
Yeah, it really sounds like that, and lots of growth opportunities in the coming year, which is great. I think just kind of closing up as a final question for you, Andre. The theme of our podcast series and our annual Biochar conference coming up in October is Biochar in the Carbon Drawdown Decade. So, how can putting biochar in roads help with carbon drawdown?
Well, if you look at the biggest emitters in the world, that's definitely the industrial age. We cannot, without very expensive and very advanced technology available to us now, I cannot see any other carbon drawdown application that can be as big as what we can do into roads and construction. We've done a little model, so it's not official, but we've done some Excel modeling and database modeling. And to compare, if we today resurface all the roads in America, we wipe out at least 15 years of carbon emissions in America. In America, are they the biggest? Is China the biggest? We're not sure. The amount of, and it's not only the carbon sequestrated, again, it's emission avoidance. If you put that together, it's difficult to quantify it now because there's no official carbon accounting platform for the construction chart at this stage of the game. But our internal calculation shows that if it was possible to do all the roads in America, you've wiped out 15 years of carbon dioxide emissions. That's significant.
All right, thanks, Andre. We might wrap it up there. So I guess the best way of making contact is through the mps.world website. Would that be right?
Yes. Yes, at this stage, our apologies. Our new website was supposed to be up and running last week, but with everything that's been happening in New South Wales, everything got delayed. So at this stage, an email to myself, andre@nps.world is good. And we'll definitely get back to you, and we would love the support to expand as quickly as possible. Let's go carbon negative together.
Yes, indeed. Thank you, and thank you, Sam, for co-hosting today, and also Andrew Kindon in the backstage. Thank you to all the viewers and listeners for joining us, and we hope you found it valuable. So this interview is going to be uploaded onto the ANZBIG Vimeo and YouTube channels and available for download as the Biochar podcast. So up next week at the same time, same channels, is the chair of ANZBIG, Nigel Murphy, also director of Earth Systems and producer of Green Man Char and Wood Vinegar. And he's going to be talking on the development of ANZBIG's Code of Practice for the sustainable production and use of biochar in Australia and New Zealand. So it should be a good lead on from this podcast. So thank you again to everyone, and until next week, cheers.
Thank you.